Doug Russell, Senior Design Engineer at Specialized. You're responsible for the new Crux 5. Can you talk us through the design process and through the bike, all the elements?
Yeah, so the new Crux 5 is really a all new frame fork system of a bike that we developed specifically to be optimized for gravel racing. So we really wanted to find a lot of aerodynamic gains for this new bike compared to the Crux 4, evolve the geometry to be better suited for gravel racing, and provide all of the clearances and compatibility that the racers are really needing with gravel racing these days. So this whole design process started as a exercise in understanding how much aerodynamic improvements could we make to the chassis while also keeping in mind weight as a primary focus. The Crux 4 was really well known for being a super light bike and a really responsive, well-handling bike, and that's what so many people loved about it. And with the new Crux 5, we wanted to add a lot of aerodynamic improvements, but retain the lightweight chassis that people love about the Crux 4.
Yeah.
So there was a really deep process of understanding where we could make those aerodynamic gains and what the weight trade-offs would be for each of those changes. So it's an all-new frame, fork, wheel set system, and cockpit that are all developed with as a system for Crux 5.
Yeah, let's start with the wheels.
Yeah, the wheels are the Terra Aero CLX wheels are what come spec on the bike. These have been out for a little while actually, but they were really developed in tandem with this chassis together. They are a big aerodynamic improvement from a gravel wheel set perspective, 27 millimeter internal width to fit the large volume tires that gravel racers are running now. And they follow the design philosophy of all of the latest road and gravel wheel sets from Vooral, which is the front rim is deeper than the rear rim. And that's really to get as much aerodynamic performance out of the front wheel, where that cutting into the clean airflow and the leading edge of the bike sees the most aerodynamic improvements. And the benefits from that deep rim are really utilized. And then the rear rim is slightly shallower to maintain a lightweight wheel set system. And the aerodynamic gains from making the rear rim much deeper aren't as great as those on the front. So it's really a balancing between gaining as much aero performance as we could with the front wheel and still keeping a lightweight wheel set by keeping the depth of the rear wheel a little bit smaller.
Yeah, and we got what is also new and a really big design choice here that's been made by you and the team is that it's a one by only for the Crux 5.
Yeah, so being that it's a gravel focused bike, the Crux 5 is now one by only. That was a decision we made because all of the feedback from our athletes was really that one by is the way they want to race the bike. And it also opened up a lot of design opportunity around maximizing chainring clearance and tire clearance. So we had a target of fitting a 55 millimeter tire on this bike with ample mud clearance on top of that, and also fitting up to a 52 tooth chainring, which was direct feedback from our gravel racers that these races are getting so fast, they are really pushing the pace, and having the ability to at least run up to a 52 tooth for very specific courses was something that they said was a must have. Yeah. So by going one by only, it did open up the opportunity to fit both that tire clearance that we wanted to target and the chainring clearance that we needed.
Yeah, and you got even at the front, you have really a massive amount of space left here.
Yeah, absolutely.
With the 50s on, right? This is the 50s,
these
right?
are actually 45. The bike will
yeah.
come spec'd with 45 Pathfinders
yeah.
as the default tire on, I believe, all models of Crux. But as I said, it does fit up to a 55. And as
then
you
still have 2 or 3 millimeters of
5
space.
plus millimeters of clearance to a
Both
55.
sides.
Yeah, both sides has at least 5 millimeters of clearance at the minimum. But as you noted, the fork crown has an additional amount of space to account for mud, because we see a lot of these gravel races are really muddy conditions.
Yeah.
I don't know if you recall
with the bad weather. Yeah,
absolutely. Like Unbound a few years ago, if you recall.
Yeah, 2024 it was.
2024.
The mud edition.
They had all the paint sticks taped to their top tubes to be scraping mud. So we did want to ensure that there was as much mud clearance as possible, front and rear, on this frame, in addition to fitting those 55 millimeter tires. So you'll see around the top of the fork crown, there's a lot of extra space. Yeah. And also in the rear of the frame, in front of the seat stays and around the bottom bracket area, we tried to ensure that there wasn't any places for excessive mud to collect.
Yeah. What other design choices have you made? Because you were in the design team. You've been working on this bike for
roughly three years. Yeah. So I was the lead engineer for this project and for the frame and the fork specifically. And the main goal for the frame and the fork was really to get as much aerodynamic gains as we could, but keep it lightweight. So I went through a process of understanding through prototyping different iterations in the concept phase, different tube shape changes throughout the frame to quantify how much aero gains we could get out of each zone. For example, just an aero seat post and seat tube, what would be the expected aerodynamic gains? And then balance that with an understanding of how much weight gain might or may not be associated with those changes. Yeah. So we were able to take a piecemeal approach to say, we can see this much aerodynamic gains for some weight penalty here. We can see this other area of the frame contributes a different amount from aerodynamic performance. And then we could make the decisions throughout the design process of, okay, what areas will we get the most bang for your buck as far as aerodynamic performance for a minimal weight trade-off, and focus on shaping the frame in a way that gives us the maximum aero benefit with the minimum amount of weight penalty associated.
Wow.
So one example I can show you here is actually a frame that we did in the concept phase of the project, where this is actually a Crux 4 frame. Yeah. And it has a Tarmac SL8 seat tube bonded in to the frame. So the only change on this entire frame was the seat tube and seat post going from round to aero. And with that, we were able to walk downstairs and do our composite shop, bond this frame together into this prototype. The following day, take it right across the street to the wind tunnel in Morgan Hill at our facilities, test it and say, now we have exactly the number of aerodynamic counts of improvement we might see from an aero seat post and seat tube, and also a direct weight comparison of how much weight would we see as a gain or loss from going from the round to the aero shaping. And this was one of the tools that we used in the concept development of the project to quantify what is the aero gains we might see and how much weight would those cost.
Yeah, so and there's also a relation with the to be released Tarmac 5. So the new Tarmac, you worked also closely together, right?
Yes.
Because it's two product teams in a way, road and gravel, but
right.
You work together.
We are one team. We're the road and gravel team.
Oh, road and gravel team.
Yeah,
okay.
So we have our team is spread across multiple offices in both Morgan Hill in California, but also in Germany. And we actually work really closely together, though, and are
Makes
constantly
sense in a way also.
Absolutely.
Why split it? Yeah.
Yeah. So like we learn from each other. We grow on each project, and anytime we get some good insights or layup development strategies, we're sharing that information with each other. So this bike has been a culmination of development from the flow state design philosophy that Specialized has been using now for a while, sort of starting with Athos 1 and evolving through that to Tarmac SL8 and Athos 2 and into Crux here as well, where we're really taking a philosophy of design that takes 3D shaping into account from a 3D design standpoint, pairing that with an FEA analysis to show what would be the expected stresses that frame would see in all of the critical load cases from stiffness and strength, and then feeding that directly into a carbon fiber simulation software that shows us with this shaping and stresses what would be the carbon fiber layup that we need to make a frame that passes all of our stiffness and strength requirements. And that feeds directly back into potential 3D shape changes to optimize further. We might see that there's a high stress zone in one area of the frame from the shaping through the FEA and ply-by-ply analysis. And that might inform us on how to adjust the shaping of the frame to use less carbon to reinforce it. By geometrically optimizing the design to reduce stresses, we then need less material to reinforce those areas of the frame, and that helps really focus on keeping a lightweight chassis at the end of the day.
Yeah, we talked about that after the test ride here. So the lightweight chassis can come in, it has multiple benefits, but the frame at itself, what does it weigh?
The size 56 frame comes in at 789 grams.
Yeah.
So still extremely light, and complete packages at the S-Works bike with the Terra Aero wheels come in around 7.2 kilograms.
In total?
In total as a full complete bike. With the Terra C or the Terra CLX3 wheels, you can have full builds as low as 6.9 kilograms.
Let's discuss the cockpit some more. What was the philosophy here? Because it was a existing cockpit, right?
No, this is actually an all-new cockpit developed
also
with Crux and specifically for Crux. Yeah. It's a gravel optimized cockpit. It's a one-piece carbon bar stem combo, but it's got really designed specifically for gravel use. So it has a short drop compared to the Rapide and Alpinist cockpits, similar to the Terra bar that was previously used on the Crux 4. it has a slight back sweep built into the tops of the handlebars. And that is so that with gravel riding, with gravel riding, you end up holding the tops of your bars a lot more than you might in road. And we wanted to shape this in a way that was both comfortable to hold on to, so from a cross-section perspective, but also that slight amount of back sweep means that when you're holding it, your wrists are turned into a way that lets your elbows stay tucked in. Exactly. Kind of making sure that when you are up there, you are able to hold that narrow position comfortably. And the third really important part with this cockpit is that it was built to be really compliant. So this cockpit is 83% more compliant than a Rapide cockpit of the same size. With gravel riding, you're doing a lot of really rough terrain, and often you're in the drops just hammering along for 8, 9, 10 hours for a race, and making sure that this handlebar was comfortable to hold on to for that entire race time or any ride. It was a big focus, and that was achieved through both the shaping of the tops and also the carbon fiber layup within the handlebar itself.
Cool. Thank you so much for this grand tour on the Crux 5.
My pleasure.